In this very lesson, we shall be looking at De Morgan's law for set theory. De Morgan's law for set theory. This law was named after a great British mathematician and a logician as well. So this guy is called Augustus De Morgan. So this guy was able to come out with two laws in set theory. Now what this guy is saying is that if you have two sets or given any two sets, then the complement of union of these two sets is equal or is the same as the intersection of their complements. And then the second law, which is called De Morgan's law for intersection, this guy said that given any two sets, then the complement of intersection of these two sets is equal or is the same as what? The union of their complement. This is what this guy was able to come out with some years ago. So our task is to verify, to see what this guy said some years ago is actually true or not. So we are going to look at the first law, which says that the complement of union of two sets is the same as what? The intersection of their complement, which is also called the De Morgan's law for union. So you are going to verify that using what? Sets. Okay, so let's take it that you have the universal set U, which contains the element 1, and then you have a subset of the universal set, let's say set A, which contains the element, and then you have another set, set B, which contains the element. We want to verify the De Morgan's law, but we are going to start with what? The first law. So the first law says that we want to verify to see if the complement of union of two sets is the same as what? The intersection of their complement. This is what this guy is saying. So let's start. So we have this set U, set A, and then set B. We are going to use this set to verify to see if the left hand side will be the same as what? The right hand side. So we are going to start with what? A union B. Before we can find A union B complement, we have to first find what? A union B. So from here, A union B means that we are going to combine all the elements in A and B into a single set. So we have 3, 4, 5, and then what? 6. Good. Now our A union B all complements. It means we are going to look for those elements in the universal set that are not in A union B. That becomes what? The A union B complement. All elements that are in the universal set but cannot be found in A union B. Those elements becomes what? A union B complement. So we have 3 here, 3 is also here. We have 4, 4 is also here, 5, and then what? 6. So those elements that remain ununderlined becomes what? The complement of A union B. Good. So we are left with what? 1, 2. So we have 1, 2, and then 7, and then what? 8. Good. So we are done with what? The left hand side. Let's move on to the right hand side. So the right hand side we have A complement intersection what? B complement. Before we can find the sets of A complement intersection B complement, we have to first find our A complement and then B complement. So A complement, we are going to look for those elements that are in the universal set but they are not in set A. So we are going to have 3, 3, 4, 4, 5, 5. So those elements remain in the universal set become the complement of A. So we have 1, 2, 6, 7, 8. So we have 1, 2, 6, 7, and then what? 8. Now let's look for B complement. So B complement, we are going to look for those elements in the universal set that are not in set B. So we have 4, 5, 4, 5, 6, 6. So those elements remain in the universal set becomes the complement of B. So we are left with 1, 2, 3, 7, and then what? 8. So we are going to find A prime intersection what? B prime, meaning we are going to look for all those elements that can be found in A prime and then B prime, or elements that are common to these two sets. So realize that we are having what? 1 is common, so we have 1. 2 is also common, we have 2. 3 is not common, 6 is not common, 7 is common, so we have 7, and 8 is also common. So at the end, we are having what? 1, 2, 7, 8. Now let's compare this set and then this set. Are they the same? They are the same, because looking at the elements in A union B or complement, we are having 1, 2, 7, 8. And then looking at A prime intersection B prime, the elements too, we have 1, 2, 7, 8. Therefore, we can say that A union B or complement is equal to what? A prime intersection what? Good. So we can all observe and agree that what this guy said, or the law that this guy was able to come out with, is actually true. Now with the same preamble, let's look at the second law. So we are going to look at the second law. So the second law says that given any two sets, then the complement of intersection of these two sets is the same as what? The union of their complement. That is what the second law is saying. So we have to write it down. The complement of intersection of two sets is equal to the union of their complement. So what we are going to do is that we are going to start with what? The left hand side before we move on to the right hand side. So with the left hand side, we have A intersection B or complement. But before that, we have to find what? A intersection B. So it means we are going to look for all those elements that are common to set A and then set B. And we are having what? 4 and then 5. 4 and 5. So we have 4 and then 5. Then we find the complement of this set. So we are going to look for all those elements in the universal set that are not here. So we are going to have 1, 2, 3, 6, 7, and then what? 8. So A intersection B or complement, we are having what? This element. Now let's look for the right hand side. So the right hand side, we are having what? A complement union what? B complement. So we are first going to look for the element of A complement. So A complement means we are going to look for all those elements in the universal set that are not in set A. So we have 3, 3, 4, 4, 5, and 5. So all those elements remain becomes the complement of what? A, because they are in the universal set, but they are not in set A. So we have 1, 2, 6, and then what? 7, 8. Now let's look for B complement. So we are going to look for all those elements in the universal set that are not in set B. So we have 4, 5, 4, 5 is also here, 4, 5, 6. They are all in set B. So all those elements remain in the universal set becomes the complement of B. So we are going to have 1, 2, 3, 7, and then what? 8. So therefore, A complement union B complement, we are going to combine all the elements of this, of A complement and then B complement, into a single set. So we are going to have 1, 2, 3, 6, 7, and then what? 8. So this is the right hand side, and we can all observe that the element in the left hand side is the same as what the element in the right hand side. So we can therefore conclude that A, the complement of intersection of two sets, is the same as what the union of their complement. So what this guy, De Morgan, is saying is actually true. That is that for De Morgan's law. This brings us to the end of today's lesson. See you tomorrow. Bye bye.